This is day 2 of comparing decimal values using symbols. I want you to review your place value chart. This is really important when you're comparing numbers that involve decimals. Pay close attention to the tenths, the hundredths, and the thousandths. Now, after studying the chart, I hope you know that 0.2, well, the 2 is in the tenths place, and the 5 is also in the tenths place. So now I want you to picture my brother and I ordering pizza. So I choose to order a cheese pizza, my brother chooses to order a pepperoni pizza, and I am able to eat 2 slices out of the 10 pieces. And Josh's pizza is also divided into 10 slices, and he is able to eat 5 pieces out of those 10 slices. So who ate more pizza? Well, my brother ate more pizza. So when I'm recording my inequality, I would say that I ate the 2 tenths, which is less than the 5 tenths that my brother ate. And then if you compare them on the number line, 0.2 is further to the left on the number line, so it is smaller than 0.5. Okay, but now we're changing these so that they're negative values. So now what I want you to do is think about the fact that this is a smaller amount, so it's now a smaller negative amount. So it's not going to be as far to the left, it's actually closer to 0. So now that value, since it's negative, is larger than negative 0.5, because negative 0.5 is further to the left, and the further to the left you go, the smaller the numbers become. So now, negative 0.2, that value on the left, is now larger than the negative 0.5, the value on the right. Okay, now we're comparing different size pieces. So let's think about our place value again. And this is the tenths place. So we have 4 tenths on the left. And then over here, tenths, hundredths, we have 4 hundredths. Well, what we could do here is we could just compare 2 slices of pie, and this pie is sliced into 10 pieces, and these pieces are sliced into hundredths. So just think about it, how this slice is larger than one of these slices. So if you have 4 of these larger slices, that's going to be more than if you have 4 of these smaller slices. We could also compare them in another way. We could change these so they're the same size pieces. For example, I could change 4 tenths to, if I add a 0, this would be 40 hundredths. All I'm doing is I'm scaling up. So I multiplied the numerator by 10 to get 40, and I multiplied the denominator by the same number to get 100. And if you multiply both the numerator and the denominator by the same number, we create an equivalent fraction. That's how you create an equivalent fraction. And now we can compare 40 hundredths to 4 hundredths. So once again, it's going to be the same amount. Now I'm just approximating because I'm not going to actually color in 40 of these, but that's about 40 right there. And then we're going to compare this to 1, 2, 3, 4 hundredths over here. And 41 hundredths is much larger than 4 hundredths. Okay, let's use that same trick here. And we're comparing right now tenths, hundredths, thousandths, 203 thousandths to 27. This is tenths, hundredths. Well, what I can do is I can just add a 0 here, which just means that I'm scaling up. So it's like I multiplied the numerator by 10, and I also multiplied the denominator by 10. So now I have 270 thousandths compared to 203 thousandths. And this amount is larger, or you could say this amount is smaller. Now the reason why we can just compare the decimal values is because the number in the ones place is the same. They're both nines. So that's why we had to move to the decimals to make our final comparison. All right, now take a look at this example. We have -6 and 800ths and -8 and 8000ths. So we're using that trick where we just add a 0 to make it easier to compare. So 800ths compared to 8000ths. Now I like to draw it on a number line when they're negative values. So -6.08 is not going to be as far to the left as this larger negative. So a greater amount of negatives is going to be further to the left. So that means that since this is closer to 0, it's closer to the positives, it's larger. So we would write a greater than symbol here. And then this is the last example, and I hope you realize that having a 0 in front is not required. So we don't have to have the 0 here. So this -0.05 is the same as this -0.05. They're both -500ths, so they are equivalent.